Hello everyone, this is Jean from Linkurious. We are about to start. Thanks for joining us for today's webinar. Hello, today's webinar will be dedicated to PLM or Product Lifecycle Management. This is our first webinar on this topic, which is a very new and exciting topic for us and a topic of interest for a lot of our clients. So first, a quick word of introduction. My name is Jean Villedieu. I'm one of the co-founders of Linkurious, and for today's webinar, I will be joined by Elise.
Hi everybody, I'm Elise. I'm the marketing project manager at Linkurious, and thank you for joining.
So let's discuss today's agenda. We will start by a brief intro about Linkurious. After that, we will dive into what is graph technology. We will then discuss product lifecycle management and its associated risks and challenges. After that, we will present the benefits of using Linkurious. We have also prepared for you a demo in which we will showcase Linkurious on a PLM dataset. And finally, we will explain the technical aspects of the product, share a few case studies, and at the end go over a few questions. During today's presentation, feel free to ask questions in the chat section. So let's get started. So Linkurious is a graph visualization startup based in Paris, founded in 2013. Today, we have about 40 plus clients around the world in 20 plus countries. Among our clients are NASA, the US Space Agency, Cisco, or the French Ministry of Finances. We have two main products: Linkurious Enterprise, which is an off-the-shelf graph visualization and analysis platform, and Linkurious SDK, which is used to build custom bespoke solutions. What is graph technology? You've heard me since the beginning of the presentation talk about graph a few times, and perhaps this is the first time that you are hearing this name. So a graph is a data structure that consists of nodes and edges. So a graph is really just another way to talk about data. Today, a new technology has emerged, graph databases, which is designed to facilitate the storage and processing of large connected graphs in real time. Our software at Linkurious helps analysts easily detect and investigate insights hidden in graph data. On the right, you can see a brief overview of these different aspects of graph technology. So what is graph technology used for? Here you can see an overview, once again, of the use cases in which Linkurious products are being used. Some of our clients are looking at cybersecurity and are interested in connections between servers, switches, routers, and applications, and are using Linkurious to detect and investigate suspicious activities. With the same sort of data, we have clients in the field of IT operations running impact analysis or root cause analysis in complex IT infrastructure. In the field of enterprise architecture, we help organizations look at connections between servers, applications, metadata, and business objectives. And with all products, they conduct data lineage or curate an enterprise architecture. We also have clients in the field of government agencies that are interested in intelligence, and they typically look at connections between people, emails, transactions, phone call, and social media data. With this data and our products, they detect and investigate suspicious networks. Banks, money transfer companies, and tax agencies are using Linkurious both for anti-money laundering and for fraud analysis. And finally, we have some clients who are using Linkurious to develop new drugs. So this is a brief overview that should give you a bit of an understanding of the wide range of use cases that can be addressed by Linkurious graph technology.
Yeah, thank you, Jean. Yeah, in this second part, I'm going to review for you some of the stakes and challenges of product lifecycle management, or PLM. And I will also go over the advantages you can find in using graph technology like Linkurious. So first of all, here when we speak about PLM, As you might know, we refer to the process of managing the entire life cycle of a product, from design stage to development to go-to-market to disposal. And this practice has been spreading among the largest manufacturing businesses in the world. And either if you are in the industry of aerospace or consumer goods, energy, or high-tech electronics, at one point you need to cope in one way or another with the complexity of developing products. And that's where PLM can assist. It helps you lean toward a few things that we will go over here. So first, PLM is a good way to increase productivity. And this is the case for different stages of your product development. For instance, if you're a product lifecycle manager, you can work on bills of material management, and by helping to automate their processing or by increasing the collaboration between departments, it will save time for everybody, and in the end, it will lead to an increased productivity. One of the other advantage of PLM is that it can also have an impact on the product quality. For example, let's say you work on the production's processes to reach a certain transparency. Well, in case a deviation occurs, it enables a rapid intervention. Or if you identify a product failures in one of the late stage of the life cycle, it's then much easier to track it back and to perform root cause analysis. So yeah, all in all, PLM helps provide feedbacks, and not only for the current products, but also for the next ones. So the third advantage is that PLM helps to reduce the cost for your businesses. Because if you have a solid product data management system, for instance, you will be making savings through the reuse of original data or through the integration of engineering workflows. And in the end, you will lower the cost of new product integration. And finally, you will also work on the risk for your businesses. If you set up a centralized access to product documentation and all along the development stages, then it will definitely be of some help improving compliance for governmental regulations or for traceability controls. So yeah, PLM will have an impact on your strategy. It will improve it in many ways, but as you may know, the implementation or the maintenance of such systems is not without complexity. So this is the point of this part of the presentation, is that today the existing PLM software rely on relational databases. And at the same time, you probably have each domain data in your organization scattered in siloed tools. That could be SAP, micro application, ERP, or any kind of document management system. And those actually cannot be leveraged properly by relational technology, because their underlying model for those databases is a model of rows and tables, like in a spreadsheet, for instance. And modeling the data, modeling the dependencies is very hard in this situation. That's why actually vendors added an additional abstraction level to their storage solution, so you can correctly model your data. But in the end, the underlying technology is still relational. So in PLM, what you need is a maximum flexibility. And relational databases are very limited when it comes to changing or making the data model evolve. And plus, if you're looking for insight that requires to query connection across tables, at one point, relational databases will quickly show their limits on that. And yeah, because they were not designed for such use. So yeah, all in all, the limitation of this technology will impact how you manage your product lifecycle and data. And if you have new products coming in, or application, or I don't know, a new department, it will be complicated for you, it will be costly and time consuming to update the data model that you have built. And you will probably have issues scaling up with the data complexity. Another limitation of that is searching and navigating through all levels of data is probably very complex and time consuming because of the limitation we just mentioned in the technology. And this is actually where engineers spend from like 12 to 30% of that time, according to multiple researches. And yeah, in the end, you might not even be able to retrieve the information you were looking for. And you can also miss insights about certain connection or dependencies. And this definitely is bad for the decision-making process. So for these issues, graph technology actually has some answers. And this is what we're going to talk about here, some of these advantages you could find with graph technology. So the first one, the first advantage with this approach is that you have more freedom regarding changes and innovation, because the data model behind graph technology is way more adaptable than the one behind relational technology. And yeah, the second point is it will help you reduce the time you spend searching for information, even in large data sets, because as you will see in the demo later on, it's way more intuitive to navigate through data and to find the answer you're looking for. And third point is, yeah, it also provides a better access to insights about dependencies and connection, because with graph technology, it's all about connection within the data. And visualization will give you additional context to enrich information, so you don't miss any important insight that you have in your data. So just to go a bit deeper on that is regarding the data model. What is especially interesting in product lifecycle is how your data is interconnected and how to generate insights from it. And graph technology, they allow to model, to store, and to access the data as a single graph, which is way simpler than tables. It's intuitive. And this is perfect to interconnect multidisciplinary data about products and processes, and to actually get a complete cross-domain view of your product lifecycle, which makes more sense than silos view. So you get to see the totality of your assets, processes, documents, and everything, and how they are connected to each other through every single stages of your product development. So you can also expand the graph model as you change your strategy, or as you have new department or data coming in, and it's totally flexible in that way. You can either add new type of data through the graph model, or you can even do it directly into Linkurious, for instance, and it doesn't require special technical skills. So it make things easier. And regarding the access to insights about your data, there are many ways in Linkurious to explore data depending on what you are trying to achieve. So if you are investigating dependencies for root analysis purposes, for instance, you can visualize either specific elements, or you can access visualization of the whole graph or even subparts of it. You can filter your data to display just like the type of element that is relevant to you. You can also use graph query language. They are very simple, and it helps you look for dedicated groups, or to look for some patterns. And yeah, in the end, you get a better access to insights. So you might miss important information when looking at data on in a tabular way, but graphs let you model connection between entities and get the big picture that you need. So yeah, everything is represented in a graph visualization, so you can see in a glimpse which elements depend on what and what are the central nodes in this graph, what they are made of. But yeah, we've prepared a demo to demonstrate all of these, and yeah, we will. That's going to be the next part. So I will let Jean go on for that.
Thank you very much, Elise. So switching to the demo now. So as Elise was saying, we have prepared for you a demo centered on a PLM dataset, and so we'll talk a little bit about this dataset. So this is coming from the work of Rick van Bruggen. We have taken a dataset that he has prepared for his blog, and you can see in this dataset that we will be looking at entities like product categories. So here we have a product category. We can see that in a dataset, the product categories are connected to products. Products can be connected to components, and these components can be connected to subcomponents. And subcomponents can be associated with suppliers. So we have 4 distinct types of nodes: the product categories, the products, the components, the subcomponents, and then the suppliers. So five types of nodes. And now we are going to switch to the demo. This would be the Linkurious Enterprise interface. And in today's demo, we are going to see how to quickly identify the subcomponents associated with a given product. So this will be a BOM analysis. And after that, we will try to assess the impact of a supplier failure on a product line. In both cases, what we will see is that Linkurious makes it very easy to navigate the web of entities associated with PLM data to find answers. But first, let's start with our BOM analysis. So we are going to look up a product category. I'm interested in bikes, so I can quickly look that up with the Linkurious Enterprise search engine. So here is a product category. I can see that it is connected to 10 entities. I can quickly retrieve these 10 entities by double-clicking on the bikes. And what I can see is that there are multiple products associated with the bikes. So potentially multiple bikes. What I want to look at right now is this particular product called product 1, and we want to see what are its components, subcomponents, and suppliers. So let's dive into that. I'm double-clicking. Right now I can see that there are 6 components that come into play to compose product 1. I can dive deeper into the data. For example, looking at component 1, I can see that it's connected to 5 of entities. I'm double-clicking on that. And what I see appearing on my screen at this point is the different subcomponents that are part of component 1. Okay, and I can click on any of these subcomponents, like for example this one, and I can see that all of these components are actually associated with the same supplier called Supplier 5. Okay. So we have a supplier, we have a series of subcomponents, we have a component, and finally a product and a product category. Okay, so we started from the category and we arrived to the supplier. There's a bit of a hierarchical element to this data, and if we want to highlight that, we can switch from this 4-0 layout to a hierarchical layout. So I'm going to go ahead and do that by clicking here and choosing to display data from bottom to top. So once again, we have bike on the top, and here we can see the supplier. What's interesting about the kind of analysis that we conducted is that in a few clicks, we were able to explore multiple levels of hierarchies, starting from the products to arrive to the suppliers. And we can go in any directions. If I want to learn more about that supplier and other subcomponents it is associated with, I can double click. If what I want to know is what are the entities associated with product 10, once again I can do that. The Linkurious interface gives me a lot of freedom in terms of exploring the complex connections associated with BOM analysis. So right now we have done one first scenario, that BOM analysis scenario. At this point, we are going to switch to something a little bit different. What I want to do now is to assess the impact of a failure from a potential supplier. So I'm going to start by looking up my supplier. It's called S180. Okay, looking it up. So here is our supplier. I can see that it is associated with 3 other entities. I'm going to go ahead and double click. So we see a few some subcomponents popping up. So what that means is that this supplier is supplying this component here, this one, and this one. Okay. Maybe I want to know more about that particular subcomponent. So I'm going to go ahead and double click. So we have some new data that pops up on the screen. We can see first component, another one, and another one. So in total, this supplier products are associated with 3 and 4 components. Okay, so that gives me a little bit of better understanding of what would be the impact of that supplier failing to deliver the goods that is usually delivering to the company. If he stops delivering this subcomponent, and this subcomponent, immediately the following components are going to be impacted. Okay, so we have started from the supplier, go to an extra layer and identify the subcomponents, go one extra layer and identify the components. At this point, we may want to go even deeper and try to assess what would be the products impacted by this potential failure. So I'm going to do a right click, select all the nodes, and choose to expand the relationships to identify not the subcomponents that are connected to these various components, but specifically the products that are connected to the components. So I'm going to go ahead and click. Okay, so there's some new information that pops up, and specifically we have a new product here and another one here. So what that means is that if that supplier fails, then all the subcomponents in blue fail, which in turn mean that the components in orange will fail, and finally the impact will be felt by these 2 products, product 1 and product 9. And at this point, if I want to know exactly where these products, in which category they are, I can also expand to find that, and I can see that both in the bikes product category. So what we have seen right now is how easy it is really to explore dynamically the data and find answers, even though this data can be quite complex. Okay. Now I'm going to switch a little bit to a different scenario. Selecting everything, removing the nodes from the canvas. And I'm going to use something a little bit more analytical, where we are going to use a query language, the Cipher query language, to identify a particular pattern hidden in the data. So to do that, I'm going to go here, click on Find, click on Patterns, and here I'm going to load an existing pattern. So I'm clicking on Load, I'm selecting this pattern, and basically what this pattern does is that it identifies the components which have the most subcomponents, and thus which can be the most fragile. So I'm going to click on Load. We are going to click on Preview Results, and Linkurious immediately returns the most fragile components. Okay, and I can see these different components. So here we have one component connected to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 subcomponents. So to function, that component needs all of these subcomponents to work. A failure of any of these components would result in a failure of the component. And I can look at all the other components. So if I were to have an interest in making my PLM, my products more resistant to change and to failures, perhaps these components would be a good place to start. Okay. Now I'm going to go back to the Linkurious dashboard and conclude by saying that what we have seen so far is how easy the Linkurious enterprise interface makes it to dynamically explore data and retrieve information. In addition to this graph investigation interface, you also have the ability from the Linkurious enterprise product to share and publish visualizations to enable collaboration across colleagues. You also have the ability to manage access rights to make sure that the right persons have access to the right part of the data. And finally, you also have the ability to streamline the monitoring of data by turning graph patterns into alerts. So all of these features makes the Linkurious enterprise software a really robust platform for the analysis of graph data. I'm going back to my presentation. Okay, and I'm going to talk a little bit more about what's behind the scenes for this demo. So typically, all software or clients start with data stored in legacy systems like ERPs or like traditional databases. They move this data to one of the graph database that we support, and we support today technologies like Neo4j, Allegro Graph, Titan, and DataStax. You can then plug the Linkurious enterprise software on top of these databases and immediately access the data and start using it to make smarter decisions. The Linkurious technology is compatible with Windows, Linux, and Mac, and can be installed on-premise. This is a browser-based application, so it can be accessed from any web browser. Now I'm going to discuss a little bit about some case studies and start with a first case study about project planning and impact analysis. So this is work that we have done with an international vehicle manufacturer. This vehicle manufacturer was struggling with complex products with many subcomponents, and this made it very hard to conduct change management. Questions like what would be the impact of removing a subcomponent, for example, were extremely long to process and led to slower decisions and to sometimes mistakes. So what Linkurious Enterprise has been able to provide these clients is the ability to really break product silos, to have an overview of the various entities associated with product lifecycle management, and to be able to quickly conduct impact analysis. So if I'm an engineer and I want to know what would be the impact of me, making a particular engineering piece faster or lighter, I can quickly see what this piece is connected to, and so on and so on. Another example is the work that we are doing with an international industrial manufacturer, and this is related to BOM analysis. So this organization, this company, as most industrial companies, has a lot of components they're working with, and it is therefore very complex to have a clear view of the interdependencies and analyze the effects of removing one part of a given product. So today they use Linkurious to quickly understand the dependencies between components, and this helps them quickly understand their BOM and in the end make smarter decisions. They are also using the ability to share visualizations to communicate the results of their investigations and really to drive action. So if you are interested in working with the Linkurious Enterprise technology, you can contact us directly, or you can also work with our network of partners.